Hi scholars, it's Mrs. Avedian, here to start work on pages 12 through 15 of your packet. So this is going to be something that is totally new to you, and it's understandable if it's not perfect or it's, you have a little bit of a hard time in the very beginning. I'm going to go over with you first what scientific notation is, because that's the new piece. Scientific notation uses exponents. That's why it's part of our exponent unit. And your goal today, by the end of this lesson, is to be able to know what scientific notation is and to be able to use notes. I put notes in your packet. They look like this. To use notes to change things from regular notation, standard notation, to scientific notation, and then back again. So I don't expect you to have this procedure memorized today, but I do expect you to be able to use notes, your note page, to be able to do it. So first, let's talk about what scientific notation is. It is a way to write numbers that are way, way, way too big or way, way, way too small. In fact, on your calculator, if you do a calculation that results in a number that doesn't fit in the calculator window, you get a little E there, and that stands for exponential notation or scientific notation. And it's flipping it into that. First things first, up here you have a definition for scientific notation. And when I read this definition, I pretty much went, wah, 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 wah. Like, what the heck is that? So I'm going to give you the rules for what scientific notation looks like and some simple terms. First of all, it is going to look like this. It's going to be some number, and I'm going to use n for number. So some number times 10 to a power. Okay? Some number times 10 to, I'm going to use p for a power. So it's got an exponent up there. And the first rule is that this number right here has to be between 1 and 10. Okay, so let's talk about what some examples look like that are between 1 and 10. Well, and it actually has to be less than 10. Between 1 and less than 10. Okay, between 1 and less than 10. So let's look at what that looks like. So a number that is, so it could be 1, that would work. It could be 2, there's a number between 1 and less than 10. It could be 9.999997. That's a number between 1 and 10. It could be 1.2762. Yep, that's a number between 1 and 10. So it can be any number. It needs to be written in decimal notation and between 1 and 10. Okay. This power up here, the exponent, can be positive or negative. So let's take a look at these numbers here and see if they meet those rules. So exercises 1 and 4 are asking us, is it in scientific notation? So I'm going to first look at this first number. Is this a number between 1 and 10? So it's 1 and 908 thousandths. Okay, you see it's got the number 1 over here. It's a single digit. It's okay that it has decimals. It doesn't matter how many decimals it has. It's still between 1 and less than 10. So yes. Are the following written in scientific notation? This is a big yes here. Let's look at this next one. We've got 325 thousandths. There's something wrong with this one. I'm going to give you a second to think about that. There's something wrong with this one. Okay. If you figured out that this is less than 1, then you were correct. No, because is less than 1. Okay, so it says you have to state the reason. So 325 thousandths, or 0, see, it's 0.325. That's less than 1. It has to be between 1 and a number, any number that's less than 9, less than 10. In other words, it needs to be a single digit. So let's take a look at this next one. 7 and 99 hundredths times 10 to the 32nd power. Okay, it's multiplied by a power. It is between 1 and a little bit less than 10. So this is, yes, this is in scientific notation. Number 4. We have 4 and 701 10,000ths, or as many people would say, 4.0701. This is 4, the number 4 before the decimal. 4 is definitely between 1 and 9. Doesn't matter if there's a little fraction more than 4, it's still between 1 and 10 or less than 10. So this is yes. This is in scientific notation. Okay, this next one, I will give you a moment to look at it and see if you can figure out why that one is not in scientific notation. Okay, if you figured out that this one is not in scientific notation because 18 is greater than 10, you were correct. So this one is no, because 18 and 432 thousandths is greater than 10. This next one is technically written in scientific notation, but there's one little thing we like to do with it to make sure that we know it's proper scientific notation. We would write, yes, but 8.0 times 10 to the negative 11th would be better. Would be, this stands for would be better. That would be the more proper way to write it. We like to make sure that there's always a decimal in there. Okay. This next page is asking you to use the table below to complete exercises 7 and 8. So you're going to use this table for both this page and the next page. Exercises 7 and 8. The table shows the debt of the 3 most populous states and the 3 least populous states. Okay, so let's unpack that for a second. Debt is money owed. Populous means the population. So this is the money that is owed by the 3 states with the largest population and the 3 states with the smallest population. Since the goal of this lesson was for you to be able to convert numbers into scientific notation, you have 2 options. You may either write each of these numbers up here in scientific notation, and I'm going to show you how to do that, or you may challenge yourself to answer each of the questions in exercises 7 and 8. I really want you to try to answer the questions, but if you start answering and you're feeling really overwhelmed, then go ahead and write every single one of these in scientific notation instead. Okay? So those are your 2 choices. Let's look at the first one. What is the sum of the debts for the 3 most populous states? Sum is addition. The 3 most populous states would be, they're the ones with the most population. So 1, 2, 3 here. So California, New York, and Texas. So the first thing you're going to have to do is you're going to write those 3, the debts. Okay, so 4, 7. And then make sure you're counting zeros. So you've got 1, 2, 3 sets of 3 zeros. And you're going to add all of these up. Now this fits very nicely on your paper here, but a lot of calculators would not be able to display this many digits. So if you were to put this in a calculator, there's a good chance that it's going to give you an answer in exponential notation because it can't display this many digits. So I've got my 1, 2, 3, 1, 2, 3, 1, 2, 3 sets of zeros. Now I can just do my addition normally over here. So 7 and 7 is 14, plus 6 is going to be 20. 7 and 3 is 10, plus another 2 is going to be 12. 1 and 4 is 5, 3 and 2 is 5, and 5 and 5 make 10. Okay, so there's my answer without being in scientific notation, but it wants me to express my answer in scientific notation. Here's how you do that. Anytime you are working with a number like this that does not have a decimal in it, the invisible decimal is over here to the right. So step 1 of writing numbers in scientific notation. Step 1, move the decimal until it is directly to the right of the first non-zero digit. Okay, so if I'm looking at this, when I say first, I mean the first digit from the left over here. So I need to move this decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So see, it's directly to the right of the first digit in this number, and I want to put it right there. So I'm putting it 1.02. Okay. All those zeros at the end, I do not have to recopy. But this is not my number. And scientific notation, I have to multiply this times the power of 10 so I can get back to the other number. So I need to multiply it by 10, and the way you find the power is to count how many spaces you moved it. We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So this is 10 to the 12th power. I'm going to put one of these other numbers on my page, and we're going to practice that on 2 more numbers. We're going to practice writing it in scientific notation. So I'm going to copy a number down, 407, 0, 0, 0, 0, 0, 0, 0, 0. Okay? And then number 2, so the second, Okay, so step 1 is we are going to move our invisible decimal point until it's all the way to the right of the very first digit. So our very first digit is the 4. We want to move that decimal point so that it's right there. Okay, then we need to count how many spaces we had to move it to put it right there. We had to move it 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, 6 spaces, 7, 8, 9, 10, 11 spaces. We had to move it 11 spaces, and we're moving it to the left. Okay, I want you to make a note that when we have to move it to the left, it equals a positive exponent. I know it is the opposite of what you're used to. So I'm going to rewrite this number now as 4 and 7 hundredths. I'm going to rewrite the numbers only until I start hitting all those zeros. Okay, till I start hitting the block of zeros. And then I'm going to multiply it by 10 to the 11th power. Okay, because I moved it 11 spaces. So here is this number written in scientific notation. Okay, so that is what you are going to do on your problems on this page. Let's do one. Let's do one more on here. Okay, so we move our decimal point until it's directly to the right of the first non-zero digit. Then you're going to count the spaces you moved it. Okay. And then that gives you all the information that you need to rewrite it. And all of this is written right here on your note page as well. So you have notes to show you how to do it here as well. You have them in black and white. You also have directions on how to change it back to standard form. Let's go ahead and do this one more sample. What is the sum of the debt for the 3 least populous states? Express your answer in scientific notation. So we're taking the 3 least populous. So we've got, let's write those all down here. 1, 2, 3. 1, 2, 3. The next one. The next one. It's important when you're adding that you have all of your numbers lined up from the left. So I have all my zeros lined up. So I can just copy these zeros down. I have all my, you do not need to write your parenthesis. I mean, your, not parenthesis. Oh goodness. The commas are just there to help you keep track of how many zeros you have. That's the only reason for the commas. So then we have 4 and 4, which is 8, and another 2, which is 10. Okay. Now we're going to move the decimal point. So our invisible decimal point is always here to the right. We're going to move it so that it's directly to the right of the first non-zero digit. And then we're going to count how many places we had to move it. We had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. We moved it 10 places to the left. So now we're going to rewrite this number, 1.0. We want to have that 0 to the left of our decimal, to the left of our decimal point. I'm sorry, that's the right, my other left. Oh goodness. Then we're multiplying this Ignore this one that I accidentally put down there. That was just my pen. We're multiplying this by 10. It's always 10 to the 10th place. 10 to the 10th power, okay? So 1 and 0 tenths times 10 to the 10th power. There are lots of videos on YouTube that show how to convert scientific notation. So if you need more practice, you can always go look up additional videos and you've got your notes. So C is the same. Exercise 8, what is the sum of the three most populous, the sum of the population of the three most populous states? Express your answer in scientific notation. Again, your options are to do these or to just convert all the numbers in that table to scientific notation. Exercise 9, which is page 15, which is the last page of today's assignment. All planets revolve around the sun in elliptical orbits. Uranus's furthest distance from the sun is approximately 3 4/1000 times 10 to the 9th kilometers, and its closest distance is approximately 2 749,000 times 10 to the 9th kilometers. Using this information, what is the average distance of Uranus from the sun? Okay, so to find average, you're going to take the two numbers. You're going to find the sum of both numbers or quantity, and then you're going to divide it by 2 because there are two numbers. I challenge you to do this one. I'm going to put an asterisk next to this one because this is your challenge. If you have a challenge problem, you're not required to do it, but I strongly encourage you to do it because it will help you grow in your math skills. Awesome. That was all for today's assignment. Hopefully you can get that done in about an hour. And then tomorrow's assignment is going to be the problem set, and you will do that one independently using what you learned today. If you have trouble, then you are welcome to reach out to me. I am always here to help. Have an awesome rest of your day. See you soon, kiddos.